All right, let's pull back the curtain on the magic that really brings our favorite video games to life. We're going to dive deep into the digital toolbox of a VFX artist, right inside one of the most powerful game engines in the world, Unreal Engine. You know that moment when you're playing a game and you just have to stop and stare at a massive explosion or a crackling magic spell, or even just the way smoke realistically curls around a corner? Well, that's not just a bunch of code. That is a serious art form.
And we're talking about the whole shebang, the shimmering sparks that fly off a sword, those huge magical explosions, the dust trails a car kicks up, the energy bursts from a sci-fi weapon, even the volumetric clouds that make a sky look so real you feel like you could touch it. This is the stuff we're going to break down. Okay, so to really understand how any of this is made, you first have to get your head around the single biggest concept in all of game VFX. I'm talking about the fundamental split between particles and volumetrics. Seriously, if you get this, everything else is going to click into place. So first up, we've got particles. The easiest way to think about these is just as a huge swarm of tiny individual dots. Each one could be a single drop of rain, a spark from a fire, or a piece of debris. And because they're all separate little points, they are super lightweight and efficient, which is absolutely critical for keeping a game running smoothly in real time.
Now, on the complete opposite end of the spectrum, you've got volumetrics. This isn't a collection of points at all. Instead, it's a continuous 3D field, a volume of density. Think about a real cloud of smoke. It has depth, light passes through it, it scatters in really complex ways. That's a volumetric effect. It looks breathtakingly real, but you can probably guess it's way more expensive for a computer to handle.
So this is the big split you got to remember. Particles are numerous, they're fast, they're efficient, perfect for things like energy bursts or flying debris. Volumetrics are deep, they're realistic, but they are computationally heavy, so they're ideal for that super cinematic smoke or realistic fog. An artist's job is always about picking the right tool for the right moment.
Okay, now that we've got that foundation down, let's talk about the main tool for creating all those particle effects inside Unreal Engine. It is an absolute powerhouse, and its name is Niagara.
So Niagara is Unreal's modern system for wrangling all those millions of particles. And the key phrase here is node-based. I want you to think of it like a visual flowchart, or maybe like building with Legos. Artists connect these different blocks or nodes, and each node has a specific job. You connect them together to build super complex behaviors, all without writing a single line of code. It gives artists just incredible creative freedom.
So how does it actually work? Well, at its core, it's actually pretty simple. You have emitters, which are basically the sources. They're what create or spawn the particles. Then you have systems, and these are just containers that hold one or more emitters. The best analogy is a firework, right? You've got one emitter that launches the rocket, another one that creates the big sparkly explosion, and maybe a third one that creates the lingering smoke. The whole firework from start to finish, that's the system.
And how do artists control those emitters? Well, they use these things called modules. Think of them like the dials and knobs on a control panel. You've got modules to control how many particles are born, modules to set their starting size and color, others to change how they act over time, and finally, a module to decide what they actually look like. It gives you total control, from a particle's birth all the way to its death.
Now, beyond the powerhouse that is Niagara, a great VFX artist has a whole toolkit of specialized gear for very specific jobs. Let's take a look at a couple of the most important ones.
Hey, remember volumetrics? Well, this is where they come back in a big way. VDB is a special file format that lets artists import these incredibly complex and realistic simulations of things like smoke or fire that were made in other dedicated software like Houdini. This right here is the secret sauce for getting that cinematic quality, hyper-realistic explosion you see in those big, high-budget cutscenes.
This next tool is so important. Our source material literally calls it the heart of all surface-level VFX work. And what are we talking about? We're talking about the material editor. Now, this tool doesn't create particles, but it defines what every single one of them looks like. It controls the color, the texture, the glow, whether it distorts the air around it. It is all about the final appearance.
And now for a really clever trick. What if you want the look of a super complex animation, like fire licking upwards, but you don't want to pay that heavy performance cost? Well, you use a flipbook. And it's exactly what it sounds like. It's a little cartoon animation that you play on the surface of a simple, flat particle. It's a fantastic shortcut.
And you see this technique used everywhere. It's the absolute go-to for making efficient fire animations, little puffs of smoke, and especially those quick, flashy, magical effects. It's just a classic case of working smarter, not harder, to get beautiful effects that don't slow the game down to a crawl.
And that brings us to maybe the most critical challenge for any real-time VFX artist: performance. It is this constant, delicate balancing act between making something look absolutely mind-blowing and making sure the game can actually run smoothly for the player.
Yeah, this table just lays out the trade-offs perfectly. With Niagara particles, you get really high visual quality for a pretty reasonable performance cost. Volumetric VDBs, they give you that top-tier cinematic look, but the cost is high, which is why you usually see them in cutscenes. And Flipbooks, they give you a solid medium level of detail for a very low cost, making them the perfect tool for optimizing effects all over a game.
So, the real takeaway here isn't about which tool is the best, because the best artists, they don't just play one instrument. They conduct an entire symphony. They layer all of these tools together to create something that's totally seamless and absolutely spectacular.
So let's just imagine how this all comes together. For a big explosion, an artist might start with a super high-quality VDB for that main billowing smoke plume. Then they'll layer a Niagara system right on top to add thousands of interactive sparks flying out. After that, they can sprinkle in some cheap little flipbook embers just for extra detail, and then finally they polish the whole thing with custom materials to create that beautiful fiery glow and heat distortion.
So let's do a quick recap of this amazing artist's toolbox. You've got Niagara, your master controller for real-time particles. You have VDBs for that high-end volumetric realism. You have materials to define the look and feel of absolutely everything. And you have Flipbooks as your super efficient animation shortcuts. Put them all together, and you have a unified system for building breathtaking worlds. It really is an incredible fusion of art and technology. And just understanding these basic building blocks is the very first step toward creating that magic for yourself. So I guess the only question left is, with tools like these, what kind of worlds will you create?